Hello, Advanced Algebra 2 students. My name is Ms. Versailles, and I'm going to teach you how to graph log functions. These log functions in this video are not going to have any transformations. So in order to graph a log function, remember a log is an inverse, an exponential function. So to graph a log, I think it's best to think of its inverse. And then we will reverse the x's and the y's to graph the log. So our first example, I'm going to have you think of the inverse. So the log I'm going to want you to graph is f of x equals log base 2 of x. I want you to be thinking of the inverse. The inverse of log base 2 of x is 2 to the x. To graph 2 to the x, we make our table with -1, 0, and 1. 2 to the negative first power is 1/2. 2 to the power of 0 is 1, and 2 to the first power is 2. I don't have any transformations, so I will plot those points. I know this is an exponential growth function, so I will sketch that curve. And my asymptote cuts through the y-axis at 0. So my asymptote is at y equals 0. So this is what I'm thinking in my head. I don't have to graph this, but I am thinking about this shape of an exponential growth function in my head. Now my goal today, let's do it, graph f of x equals log base 2 of x. This log is the inverse of this exponential. So my table, I'm just going to reverse. Now my y's are -1, 0, 1. 1/2, 1, and 2 are my x's. I just reverse the x's and the y's because these are inverses. Plot these points. 1/2, -1, 1, 0, and 2, 1. I know the shape of a log curve from class on Wednesday. And my asymptote is not y equals 0, horizontal. It is x equals 0 because I'm reversing the x's and the y's. X equals 0 is my asymptote. You just graphed your first log function. Let's graph f of x equals log base 3 of x. And I'm not going to go through the whole process that I wrote out for log base 2 of x. I'm just going to be thinking it in my head. So here we go. I'm going to make my table. I'm graphing a log, so -1, 0, 1 are my y's. This is log base 3. 1/3, 1, and 3. Plot my points. I'm going to estimate approximately where 1/3, -1 would be. 1, 0, and 3, 1. Not 2, 1, 3, 1, because it's log base 3. I didn't shift left or right at all, so my asymptote, draw it in, is still at x equals 0. Next one. Let's graph f of x equals the natural log of x. X and y is my table. My y's are -1, 0, 1. When I have natural log, I know that's a base of e. E is approximately 2.718. So e to the first power, 2.718. E to the power of 0, 1. E to the negative first power is 1 over 2.718. 1 over e to the first power is 0.368 approximately. I'm going to plot those 3 points approximately where they are. Sketch my log curve in there. And again, I didn't shift left or right, so my asymptote is at x equals 0. Notice when I have a base that's greater than 1, right? E is greater than 1, it's 2.718. My log function is increasing. And in fact, for all three of these, my increasing interval is from 0 to infinity. My decreasing interval doesn't exist. Right? Reading from left to right, increasing, increasing, increasing. My y values are going up. My domain for all three of these is from 0 to infinity. My range, lowest value to highest value, my y values or outputs, negative infinity, right? It keeps going down all the way up to infinity. I could ask you any other key feature. End behavior. My end behavior with these growth bases, end behavior. As x approaches infinity, function's going up. It's growing. So f of x approaches infinity. As x approaches, so now on the left side of my function, we're not approaching negative infinity. We're approaching the asymptote. So as x approaches 0, which is my vertical asymptote, as we're approaching that vertical asymptote, the function is approaching negative infinity, down to negative infinity. So this is new for us with this vertical asymptote that a log has. I could ask you for x and y intercepts. Y-intercepts? None. X-intercepts? They're all the same when we haven't shifted. You can see where it crosses the x-axis at 1, 0. What if the base now was not 2.78 of a number greater than 1? What if it was less than 1? Let's look at this last example. I want you to graph f of x equals log base 1/3 of x. -1, 0, and 1 are my y values. I'm thinking the exponential, so 1/3 raised to the -1, 3. 1/3 raised to the power of 0, 1. 1/3 raised to the power of 1, 1/3. So I can think that exponential because I wrote the inverse table. I did not use -1, 0, 1 for the x's like we did for exponentials. I used it for the y's. I'm going to plot those 3 points. 1/3. So I plotted these wrong, sorry. Start over. 3, -1, 1, 0, and 1/3, 1. I did not shift left or right at all. So my asymptote is still at 0. So this function is decreasing over time, this log function. Decreasing over time. So my increasing interval would be none. My decreasing interval would be from 0 to infinity. It starts decreasing at the asymptote and continues decreasing. My domain and range would be the same as above. My end behavior would be different. As x approaches infinity, this has a decay base. As x approaches infinity for this one, I would be going down to negative infinity. And then as x approaches 0, the asymptote, the function's going up. So it would be the reverse of when I had a growth base. So this is how we graph basic log functions. There'll be another video for graphing transformed log functions. The only other thing on your homework would be some transformations, which we did go over an example in class. But I think you can figure that out with getting the key features of these graphs. If you have any questions? Email me, send me a remind, or go to the Lit Center, ask somebody for help, Google it. You can do it. Just learn how to graph log functions. Have a good day.